So, as you have previously seen in the architecture, we are going to create service calls in the field service management solution. So the first thing we need to do is to create credentials that will allow us to access the field service management APIs. So we just sign in to the admin UI of the field service management application, and we go into clients, and here you see we have previously created one client with a client ID, and when we do that, the solution generates automatically a client secret. So we're going to use this information to authenticate and access the field service management APIs. The other API we will call is the business rules service API. So in order to do that, we first need to create a service instance of the business rules service. So we go into the sub account where we created our business rules, and in the instances and subscriptions menu, we filter the business rules service, and we see that there is a business rules service previously created with the standard plan. And for that service instance, we also create a service key which contains the credentials to actually allow us to access the service. So we click on the service key, and from this JSON content, we copy the rule runtime URL, which is the base URL to access all the endpoints available in the service. We also need the URL to get the authorization token, to authenticate to the service. So we also copy this URL. And finally, the client ID and client secret, which will be acting as a username and password, if you will, to actually allow us to authenticate to the service. Another important information that we need to get to call the business rule service is what we call rule service ID. So remember, our colleague Eddie has created the business rules and also a rule service. So here in the rule service list, we go into the settings and we pick ID. So we can view the ID in the list like here. Then we select this ID and copy the information for further usage in our CAP service when calling this rule service. If you remember, one of the 12 factors for creating cloud native application states that every configuration, every setting of your microservice or cloud native application has to be stored in the cloud platform as much as possible. So in this case, we store all the information required to create HTTP requests to external services in a destination. So in our scenario, we are going to have 3 destinations. So the first destination is to access the custom text classifier. So let's take a look into that destination. The custom text classifier that we deployed doesn't require any kind of authentication. So in that case, we just provide the base URL for the service and no authentication. Okay, we can also check the connection, and we see that we can successfully connect to that URL. So the second service that we will access is the business rule service. And for that service, we also create a destination, but in this case, we specify that the authentication method is going to be OAuth 2 client credentials. So remember, we got some information from the service key of the business rule service instance. And with that information, we create this destination. So the base URL for accessing the several endpoints of the business rule service goes into the URL field. Then The token service URL that we got from the credentials goes into the token service URL field, which is mandatory, as you can see. And finally, we provide the client ID and client secret that we got from the service key as well as the username and password to actually authenticate to the service. And the last destination is to the field service management APIs. So in this destination, we also provide the base URL. Again, OAuth2 client credentials as the authentication type. Okay. The token service URL to get the token for the field services management. And the client ID and client secret is the information that we got when we created the client via the admin UI of the field service management. So we got that information from there, and here we use to create the destination. Now we can get into the project of our CAP microservice, and for this development we are using the SAP Business Application Studio. So as soon as we jumpstart the CAP project, we create into the package.json file the section CDS requires at the end of the package.json file. And in the requires, we list each external service that we will be calling in our CAP service. So the first one is going to be the custom text classifier pointing to the corresponding destination. The second one is the business rules pointing to its destination as well. And the last one is the field services management API, also pointing to the destination that we have previously created. So as we are using destinations in our development, we will need to bind our application or our microservice to the destination service. So to do it locally, we create the so-called default-env.json file, including the vCAP services environment variable, the usual variable that we have on Cloud Foundry when we deploy our applications. So in the vCAP services JSON, we include the destination service binding, so following this information. And notice that for the destination service, we also have previously created a service key to use as credentials. And we also include the access UAA service. So we also bind this service as it is a dependency of the destination service. So in this sense, we are all set and we can start coding our application. The next step is to define, is to actually expose a service within our CAP application, right? So we will not expose any entity in this service because it's a really simple service. So what we are going to do, we will just define two types, the type message, including the message text, and the type result, which is going to be the final outcome of our service. And the result will contain the type, meaning the classification of the text, which can be complaint, compliment, or request. Based on this type, we will have the root defined by the business rules, which can be CRM, for us to create a service call in the field services management solution, or auto reply in the case of a complement. And finally, the reply message. So what needs to be informed to the sender of this text, right? It can be an auto reply thanking for the compliment, for example, or the code of a service call that has been created in field services management. Finally, we define the serve itself. So here we just defined some types. Finally, we define the service. the path for the service, which we called int-ticket, intelligent ticket, and just an action called handle message, which is going to receive the message of type message, right? And will return the result. So here's the service definition. Now let's move to the actual business logic, to the actual code. So first of all, when the service module is loaded, we connect to the three different APIs we will be making HTTP requests during the process, right? So the custom text classifier, and then leveraging the CDS connect method, we just pass the name of the service that has been previously defined in package.json, as you can see here, right? So we do the same for the business rules and for the field service management API. The next step is to create a handler to our action. So we just use the on method to define a handler, which we'll call handle message. Okay, it needs to have the same name of the action we defined in the service definition, right? And we receive a request. We receive a request when calling this action. So actions, if you remember, actions in CAP are always referred as post methods. So always accept post methods, right? First thing we need to do is from the request, we need to get the message that is coming in the payload, right? Then we create the call, the HTTP request to call the custom text classifier service. So we define the payload using the message text, and then we do a post to the service, which is being instantiated in the beginning of the service when the service module is loaded, and then we pass the payload. From the response, we get the actual classification that is coming in a property, in a JSON property called overall classification. The next step is to get this information, the classification, and based on that, we call the business rules service. So we create the business rules service payload. Or remember the rule service ID that we needed to copy from the rule service. So here we use that rule service ID, and we set the service revision as 1 because that was the only rule service we created with just one revision. So the ID, the revision, and in the vocabulary, we set the classification as the classification that we received from the text classifier. Then we are ready to create a post request to this endpoint of the business rules service, right? Which is the rule services endpoint, and then we pass the payload. So as we have the rule service ID in the payload, the service will be able to identify which business rule we will be invoking when calling the service. So the business rules runs, and as in the response, we get the action from the final route. Oh, if you remember the configuration that my colleague Edward made in the business rules, you will see that in the response we will have the action, which can be CRM or auto reply. Well, now based on this action, so if the action is CRM, we need to create a service call in the field services management solution. Okay? So let's imagine it's rooted as CRM. So the payload for creating a service call is quite extensive, but what really matters for us in this context is the message text that we supply as the subject of the service call. And for the priority, we check whether the classification is a complaint, and if it is, we set the priority to high. Otherwise, we can set the priority to low if it's just a request, for example, right? So we fill the payloads, and for the field services management API, we need to provide some special headers, right? Because the field service management solution handles its multi-tenancy, in a quite different way as BTP does. So we need to provide a client ID, in this case demo client. We need also to provide client version. We can set it to 1.0. The account ID, so which is going to be, let's say, the tenant, the tenant account for the field services management solution, and the company ID. So account and company ID will make up actually the tenant for which will be posting the service call. Now we are ready to post, to create the HTTP request by posting the payload to the API. So in this case, we will not be using the post method from the HTTP request, because we need to provide further information such as the headers. So here we just use the send method, and then we specify that we will be posting to this endpoint, so the service call, passing the payload and the additional headers, additional custom headers that the service requires. So finally, from the response, we get the code, so the service call code, or the service call ID, if you will, from the JSON that is returned in the service response. Okay. The last step is to configure the reply message. So here we simply again check the root action. So when it's CRM, so we always thank the customer for contacting us, and inform that a service call for the complaint or the request has been created with the code that has been returned. Otherwise, we can be creative here and create a very nice reply thanking the customer or the sender for doing the compliment and appreciating the service. Really, really simple. Okay. Last thing we do is we create our response following the result type that we defined in the service definition, so containing type, root, and reply message. And we do it here. So type is classification, root is the action, and reply message, the reply message that we configured here. And we return. Really, really simple. So we can do a quick test of this business logic of this project using the CDS watch command. To start our service or locally start our service. Very good, our service is started, and we can use this simple HTTP client that is actually an extension of Business Application Studio creating then a post request to our service endpoint like this, specifying that we are going to post a payload which is an application or JSON content, right? So here I created a message that I'm extremely happy with the service level I'm getting from your store. Thank you. So it is supposed to be a compliment, right? So let's see what happens. Let's just send the request. And here's our response. So if you remember, CAP is always it's a framework that is based in the OData protocol, so it always returns the OData context, right? And the result structure with the type complement. The root obviously is going to be auto reply, and the reply message as we specified in our business logic. So if you want to know more about how you connect and do HTTP requests to external services, you can refer to the official CAP documentation in the topic of core services APIs. And you can go specifically to the REST style APIs, which is the kind of APIs that we've been playing in this application. So if you go here, you will have the documentation explaining not only how you connect to the destinations and so on, but how the various methods available for calling external services can be used. The CAP service has been deployed to Cloud Foundry using the CF push command, as you can see here in the BTP cockpit. And if we go here in the service bindings, we see that we have bound the application to the destination service and the access UAA services as well, just like we did in the local project. So going back to the local project, after the application is deployed, the CAP framework secures the service by default. So before deploying the application, we just need to install the passport package, which is required when the application is running on Cloud Foundry. And to call the external services, we also need to install the HTTP client package from the SAP Cloud SDK. If you want to know how to prepare your application for deployment, you can go into the CAP documentation into the topic of deploy using Cloud Foundry. Here, you will see that first you need to build the project with this CDS build command, and also you need to add the manifest to your project with the CDS add CF manifest, which will take care of creating the contents of your manifest file, and then you will be able to push your application to Cloud Foundry. You need to be authenticated in Cloud Foundry before doing this process. As the service has been automatically secured with OAuth authentication, we need to go into the service bindings of the Access UAA service and show sensitive data, which is actually the service key with the credentials, right? So from here, again, we get the client ID and we get the client secrets and also the URL, which is the base URL for getting the OAuth token. So we need this information to make HTTP requests to this service from an HTTP client. No? So in this case, we will be using Postman. So here in Postman, I have created a post request to the service endpoint, which is the base URL, and the service path that we have defined as the endpoint for our microservice. In the authorization section, we need to get the token, the OAuth token, using the client ID and client secret that we got from the service binding. and also the access token URL. So let's just get the new access token. Okay, proceed, and just use this token. Okay, now we are good to go. So now in the body, we can specify, let's say, a different text to test our service. Okay, this one should really be classified as a complaint. So let's see what happens. Let's send. And here we have the result. Actually, it is really a complaint. So the root is CRM, and we see that a service call for the complaint has been created with the ID or code 26. Now let's get into our field service management solution to check whether the service call has been actually created. So I'm here in the field service management UI, the home page, and so I go into planning and dispatching, and then I can go into service calls, which by the way are sorted by code, service code. The code 26 has been successfully created as type unplanned. So every new service call is created as unplanned. And as it is a complaint, it is created with high priority. So if we go into the full detail, we see the full subject of the service call, which was the complaint, if you remember, and the priority high as type unplanned with all the other information that we provided in the payload of the field service management API. Now let's get back to Postman and try to do another post request to our microservice with a different text message that should possibly be classified as a request. So let's send it. And here we go. Here we have actually a request with the route CRM again. And for that request, we also created a service call now with code 27. Now let's get back to field service management and just do a quick refresh in this list. We have 17 service calls. And here's the last one, the number 27 that we have just created. We see that the service call, which is a kind of help request, has been created with low priority because it's not a complaint, and also with the type unplanned with the rest of the information. And how would you use this microservice in your broader architecture? So you may have a service that will be capturing information from the different channels that you have in the company, such as social media, instant messaging, email, and so on and so forth. So when the service captures the messages, it can leverage this microservice to do the classification and to tell what is next or what action needs to be taken based on the classification of this text. So basically, this is how this microservice would fit in a broader architecture.